Let's talk about water. So, life as we know it would not exist if water were not shaped the way that it is, if it didn't have several of the properties that it does. A lot of different things about water just make life as we know it on Earth possible, which is one of the reasons why whenever scientists are looking for possible life on other planets, the first thing they look for is water, just because it has so many specific properties that really help life out. So, life depends on the hydrogen bonds in water. So you might remember when we talked about hydrogen bonds last year, but water is a polar molecule. So this means that it has two different regions on the molecule. Okay, so it's going to have one negative region next to the oxygen, and then it's also going to have a positive region next to the two hydrogens. Okay, so polar molecules have slightly charged regions. These are not full charges, so this is not an ionic bond. These are still covalently bonded together, but it's not a perfectly shared bond. Okay, so the electrons like to spend more time around the oxygen than they do around the hydrogen, but they are still shared between the two atoms. Okay, so that's what causes that partial charge. So it's more likely that you'll find the electrons in this covalent bond around the oxygen than it is that you'll find them around the hydrogens. Nonpolar molecules are kind of the opposite. They share the electrons between the atoms almost equally, if not perfectly equal. Okay, so they don't have those charged regions because the electrons are moving around so quickly, it distributes the charge between all of the atoms. So hydrogen bonds are strong interactions between two different polar molecules. Okay, so basically you have two of these molecules get close together, two of these oxygen molecules get close together, and the negative region of one water molecule is going to attract the positive region of the other water molecule. So you're going to get the slightly positive hydrogen atoms interacting with the slightly negative atoms. Now this only happens when you have a hydrogen bonded to either a nitrogen, an oxygen, or a fluorine. Okay, so this is a very specific reaction or interaction that takes place when a hydrogen is bonded to one of these three elements. Okay, that is because these three elements are basically strong enough that they can pull the electron away from the hydrogen enough to create this level of polarity. Okay, so this is kind of what it looks like when it structures, or when it forms this structure. So you have one hydrogen or one water molecule in the center, and it actually connects out with four other water molecules. Okay, so these are looking at, these dotted lines represent the hydrogen bonds. Okay, so you have the two hydrogens, hydrogen bonding with the oxygen here. Okay, and you then have an oxygen-hydrogen bonding with each hydrogen, okay, on the central water molecule. So hydrogen bonds actually are responsible for making ice float. So usually when you have, solid, liquid, gas of the same compound, it's usually that the solid is the densest, liquid is the next step up, and then the gas is the least dense. Okay, water is different. So in water, the liquid is actually the densest, and then comes the solid, and then gas at the end. Okay, so the structure of ice actually has more empty space in it than a liquid does. So you can actually see this here. Okay, in liquid water, there's actually enough energy in this solution that it can break these hydrogen bonds. So it'll form them and break them, and so you get these water molecules moving past each other a lot more, so they're more crammed in together. However, when you get cold enough that the water starts to freeze and you start forming ice, these hydrogen bonds are going to form, and they form rigidly. So they will hold these water molecules a specific distance apart. Okay, so that ends up producing a lot more empty space in the center of the structure than you have in the liquid water. Okay, so I've actually got a really good video about water freezing, and you can actually see how it's moving around. All of the molecules are moving around, and then how they kind of slowly get stiffer and more in place. Okay. So this is what makes ice less dense than water, which is actually really helpful to life. Because if you think about, I don't necessarily see that around here, but if you think about a lake that freezes in the wintertime, if ice were denser than water, okay, you would have that ice level form on the top where the water is actually the coldest, and then because it was denser, it would actually sink to the bottom of the lake. Okay, and you would get this over and over again, where you'd get another layer of ice form on the top, and it would sink, and then so on and so forth until the entire lake was frozen solid. Now, it might not seem like a big deal, okay, but what if you've got fish in that lake? They would get crushed by the ice sinking, okay, or they would get frozen in the ice themselves, which only happens in certain circumstances and really cold winters and snap freezes and things like that. Okay, so ice and its ability to float is actually a huge deal to life on Earth. Okay, oh, and this is here as a reminder for me to talk about curling. One of the videos that you have is actually about the U.S. men's gold medal curling match in the last Winter Olympics in 2018. I know a lot of people think curling, whoop-de-doo. I'm actually a huge curling fan. I find it incredibly intense. I know that's really weird, but there's a lot of strategy that goes into it, and I just think it's really fun. But with curling, what you'll see is that you have two different types of players on the same team. You have the one person who is shooting off the rock. Actually, you have three different types. Okay, you have the one person actually shooting off the rock. Okay, so that's what this guy is doing here. Okay, you have one person standing in the back of the ring. Okay, and he's trying to help direct where this person right here is actually going to shoot that rock and how fast they're going to go, all of that. And then you have two people who have these brooms, and you can see one here. Okay, and they actually move so that their brooms are in front of this rock, and they will sweep the ice. Now, that doesn't really sound like a whole huge deal, like whoop-de-doo, but these pads on the brooms are actually friction pads, and so what they're doing is they're putting enough friction on that ice that they're melting the ice, just a little bit. Okay, so the ice for a curling rink is actually kept just below freezing. Okay, and so when they sweep the ice, they're putting enough heat into it that it's just melting a thin layer of that ice and creating just a water path for the rock to slide on, which helps the rock slide a lot better and move faster and further and all of that. Okay, so that's how curling works. And then as soon as they stop with the whole scrubbing the ice, then it actually freezes again. Okay, so it's a pretty delicate balance that they have going on there. But all right, so solution. We're going to talk about solutions quite a bit in this class. Most of biology, most of the chemical reactions that take place in biology are done in solution. So the compounds, the substances are dissolved usually in water. Okay, so a solution is when one substance is dissolved in another. Okay, and you have two different terms that go along with solution. You have the solvent and the solute. Okay, so a solute is the compound that gets dissolved. The solvent is the one that is dissolving. Okay, I know it's really kind of weird. They're very, very similar terms, but and And then you also have two different kinds of mixtures. You have the homogeneous mixture, which is an evenly mixed mixture that is also known as a solution. You also have a heterogeneous mixture, which is an uneven mixture, but we're not going to talk about that right now. Okay, so solvent dissolves other substances, and then a solute dissolves in the solvent. Okay, now whenever you have two gases that are mixed, the solvent is the one that there is more of, and then the solute is the one that there's less of. Okay, so it makes it kind of easier, a lot easier to determine which is which. Alright, so you've heard about charges where like repels like and then opposites attract, but when we talk about dissolving, it's actually like dissolves like. Okay, so polar solvents will dissolve polar solutes. So water is actually termed the universal solvent because it's so good at dissolving polar substances. Okay, because water is polar, it will dissolve any other polar solvent or solute. Okay, nonpolar solvents, on the other hand, will dissolve nonpolar solutes. Okay, so water and oil don't like to mix because water is polar and oil is nonpolar. So polar substances and nonpolar substances do not mix well. You will oftentimes get a layer between the two. So if you've ever, well, this is more of a girl thing, probably, but if you've ever used like an eye makeup remover that when it just sits on the counter, you can actually see that it forms two distinct layers. They're both clear, but there is a very distinct line between the two layers, and you have to shake it up real good before you use it. That is a polar and a nonpolar substance together in the same bottle. Okay? So this is an example here. You've got the water in the glass, and then they're pouring the oil in. Okay, and you can see how the oil beads up. Okay, because the oil, again, is a nonpolar substance and the water is polar, so they don't like to interact. Okay, and this is showing that here again. Alright, so we're actually going to stop here for this video, and then we're just going to talk about acids, bases, and pH in the second part for this.